Are you seeing my screen right now? It should say object methods. Perfect, cool. Yeah, so yesterday you and Alex covered objects, right? Okay, great. Yeah, so the solutions for that should be live now. So when you refresh your full stack account, you should see the solutions up, and then now you should also see the workshop live for object methods. So yeah, so yesterday, as a quick primer, we talked about the basic concepts of an object. Essentially, it's a way to store a lot of information, a lot of different types of information, and we do it through the key value pair principle, right? So every value is the thing you want to store, and then every key is kind of the association that you want to store it under. And essentially, it operates very much like a dictionary in the sense that when you want to fetch a value out of an object, you look up that value according to the key in the object. Today, we're just going to take that one step further now and talk about object methods, which essentially is an extension of objects. Except the only difference now is, to be more specific, now the things that we're storing are no longer just any types, but now we're going to talk more about specifically about functions that we store in objects, hence methods. So yeah, so quick overview. So we'll talk about what is a method. We'll talk about creating, access, and running a method, and then we'll talk a little bit about the idea of this THIS. It's a bit of a pain in the butt it's a bit of a pain in the butt to explain verbally, but hopefully it'll give you some idea of kind of how JavaScript objects at least are able to reference themselves. So what is a method? Methods, yeah. So there are actions you can perform on a value, and really they're just functions, right? There's actually really nothing like a method. Essentially, is a function. The only difference between a method and a function, as the way that we've typically used it, is that a method is actually just a function that belongs to an object. So what does that mean? Well, so far, for example, in this class, some of the methods that we've seen are things like .index of, right? You can never call .index of just by itself. You always do, array .index of or string .index of. This is the same exact principle for methods. Essentially, it's a function, but it's a function that belongs to an object. And so whenever you call that function, you have to kind of recognize that, hey, I am looking for the function that's associated with this particular object. So here on line 8 there, if I make an array called countries and I set it equal to that array of 4 countries there, on line 9, when I want to find out what position Brazil is in, I can't just say, hey, call a function index of and pass in Brazil. I have to say countries dot index of and pass in Brazil. Essentially, dot index of is still a function like every other function we've ever seen. We still invoke it with the open and close parentheses. We still pass in arguments in the same way we do any other functions. The only difference, obviously, is that when we call index of, we need to acknowledge that this index of function more or less belongs to this country's array or this country's object. And so if all methods are just functions that are a part of an object, well, then creating a method should actually be pretty straightforward, right? So here, if I have this Grace Hopper object with a bunch of key values, first Grace, last Hopper, and rank rear admiral, well, this is a traditional object that we've seen yesterday, and we've talked about how if we can store anything as a value inside an object, then there's no reason why we can't store functions as inside the objects. And so if I add a function to this object, now that function becomes what we call a method to the object. It's actually a lot of just verbiage. Hopefully the concept is pretty clear, right? A method is just a function that happens to belong to an object, as opposed to a lot of the standalone functions that we've seen so far, right? So if I say write me a function that takes in a string and does this, well, that's a standalone function. I just call that function. What a method is, whenever I call a method, once again, I need to make a reference to the object first and use that object to call the method. So going back to the Grace Hopper example we have here, if I want to make a function inside a Grace Hopper object, it's literally as simple as adding another key value pair. The key always has to be a string, right? That's something that Alex covered yesterday, and so that's non-negotiable, right? In this case, the key is called my method there on line 5, and the value of my method is just a function. And all it does is console logging out this message, I'm from a method. And so if I ever want to call this quote unquote method, then all I need to do is do Grace Hopper, which tells JavaScript which object I'm looking at, dot, right, which is a way to access the value in a given object. And then here we're doing my method, right? And so when I call the key my method, JavaScript knows that's a function, and then I use the open and close parentheses on line 11 there to invoke the method. Yes. No, because then if you sorry, so let me just copy and paste over this really quick. So what you're saying is here, if I do this, yeah, I understand your question. I just want to make sure I'm getting it correct here. Okay, so you're saying, yep. So you're saying if I do Grace Hopper dot my method here, this looks fine, but then if I call function here and I'll call it David, for example, right? If I call my method, it still works. But now your question is, if I call something like dot David, does this work now, right? Well, so now if I do this is not going to work. But if I go back and call this my method still, this will work. Yeah, yeah. So you give it a name, it just won't do anything. And the reason why, if I give it a name and I try using that name, the reason why it doesn't work is because look what this is actually saying now. This is saying go to the Grace Hopper object and look for a key called David. And there's no key called David. And so that's, yep, yeah. Yep. And so then the other thing to also just note here is that my method obviously works. And here we're using the dot notation. I could easily use the bracket notation too, and it will also work as well. Generally speaking, most people just use the dot notation because it's a little bit easier and a little bit cleaner. But there's nothing that prohibits you from using the bracket notation that you learned about as well yesterday. So both ways are equally fine of accessing an object method. Okay, cool. Yep. Okay. So generally speaking, when you have a method or a function attached to an object, it's more of a convention than a hard and fast enforced rule. But generally speaking, that method should have something to do with the object itself, right? Otherwise, it's kind of like, why would you put it there? And so the example here is on line 7 there, I have a method called sayQuote, right? On line 7, that's a key, is called sayQuote. The function takes in nothing, but it console logs out the sentence. It's easier to ask for forgiveness than it is to get permission. And so once again, if I do Grace Hopper.sayQuote, this is hopefully that function is somewhat or that method is somewhat relevant to the object that it's attached to. In this case, this just happens to be a quote that Grace Hopper has said before. But there's also another way to think about this from a more strict sense. So here, so here, same object as before, except now we also have another method in this object called getAge, right? And here the function takes in, this function or this method takes in a year argument, a year parameter, and just returns that year minus 1906, which I presume is when Grace Hopper was actually born, right? And so now, if I just console log Grace Hopper.getAge, I can call that function. I call it the same way I call any other functions. If it expects an argument, I pass it in the same way I pass in any other argument. In this case, 2018, and I just return 2018 minus 1906, which gives me 112. Right, so calling method and calling functions are exactly identical. Okay, and then last but not least, this works with strings, numbers, whatever. We're actually going to get a little bit more. This will actually take us into the idea of this. But before we go there, once again, I can take in a name. I can console log it out. But does everything up until now make sense to you? In terms of a method, how it's just like a normal function, except it happens to be a value in an object? Cool. Okay. Here, we're going to transition to the concept of THIS, this. And so what this is it's a reference to the object that the method is attached to. Okay. So if I have a function in this object that uses this is equal to the object that it's a part of, right? It's just like how if I'm standing in a house and I say this house, you know which house I'm talking about, right? Like so yeah, sorry, maybe that wasn't the best example or explanation of it, but yep, exactly. Yeah. So if Grace Hopper has a method that uses this, then this is the equivalent of referring to Grace Hopper. And in fact, it's just like a shortcut for referencing Grace Hopper. So let's see how like that kind of can make it live sometimes a little bit easier. So here on line 7 we have our greet function. It takes a name. On line 8 we just console log out hi name I am Rear Admiral Hopper. And the point here is that well I am Rear Admiral Hopper. We could write it out as a string, but there's two things, right? One is that it's a bit redundant, right? Because we've already determined on line 6 that her rank is Rear Admiral, and we've already determined on line 5 that her last name is Hopper, right? So it's a little bit more work typing things out. But more importantly, something like maybe her last name wouldn't change that often, but her rank might change, right? At some point she might be promoted, she might change her position, and so the fact that here I am writing down Rear Admiral Hopper, if her rank on line 6 changes, well, someone then would need to be aware enough to actually go into line 8 and also change her rank to say whatever the new rank is. And so you can kind of see how it's not really efficient, and in some ways, we actually want to just have this quote say, hey, look, I am whatever position I am now, and whatever my last name is now. And so, yeah. And so that's where, and so one thing that we could do then is to do something like this, right? I can write, hi, name, I am gracehopper.rank, comma, gracehopper.last, right? And now every time I say this, if I print out again, this looks exactly the same as the previous example. It would still say, hi, Karen, my name is Grace Hopper, or my name is Rear Admiral Hopper, right? But now I am actually very strictly enforcing this idea that the rank comes from the object and the last name comes from the object. And so if I change the rank or the last name inside the object, then effectively it would change the entire sentence, right? But I no longer need to worry that the rank is always up to date because, well, it's reading from it directly. So there's no possibility that those two ever be out of sync. So when I run it this way, once again, I see that the printout is exactly what I want it to be, right? Now I'm almost kind of I am dynamically reading from the object before I say whatever sentence I want to say. So this might seem efficient, but to some people, well, there's actually kind of a laziness component, but also a practical component too, right? Here, writing out Grace Hopper dot is actually, in some ways not very efficient either, and we'll see why that is in a little bit. But here's where the idea of this really comes in, right? So you hit a nail right on the head. This, if we use it as a method inside the Grace Hopper object, this effectively just refers to Grace Hopper. And so rather than saying Grace Hopper dot rank and Grace Hopper dot last, I can now just say this dot rank and this dot last. And yep, so if I do this, it gives me back the same exact result, right? I'm still reading from the object's rank and the object's last value, but now it's a little bit shorter type. But the other reason why this is actually a little bit more efficient too is because here we know for a fact that this object is called Grace Hopper. There are other times if we make a class, for example, sometimes we don't actually know what the instances of the class are going to be called yet because they haven't been made yet. But it's like saying I want to make an object that's going to be able to refer to itself in the future, right? Well, if I haven't made it yet, I don't know what the object's going to be called. So the only way I can reference the object that's yet to be made is going to be using this, right? It's a little bit. I'm trying to think of an example here. It's like, let's say, yep, yep. Yeah. So one of the things that actually that does happen is a lot of times people redefine what this is, as in you can reset the quote unquote what's called the context. So whenever people use this, they're basically saying what is the context of this object, right? In plain English, it's kind of like saying oh, if I say this house, what does this mean? People do the same exact thing in JavaScript. So you are actually able to reset the context of this, and that is more common than you think it is. But it's just something you want to be careful about because obviously, if you reset it, down the road, if someone else is using it, they might have a different assumption for what this is. So you just want to be clear that whenever you set it, you're actually kind of being very clear about what you're referring to. Yeah. So basically that's all quote unquote this is. It's just a context for referring to the object that you're attached to. And so one of the things that we can try here is we can say, well, on line 7, let's have a function called getThis, and on line 8, we just return this. If we store the outcome of this inside this variable called return object on line 12, and we compare the return object, that first, as well as the return object equals Grace Hopper, we'll get back, for line 14 at least, we'll get back true, right? And this just kind of proves that, once again, this that we return on line 8 is the same thing as the Grace Hopper object that we made. Yeah, take your time. Yep. Cool. Yeah. So this is just a reinforcement of what you said earlier, right? This is the same thing as a Grace Hopper object. Cool. And so we're just gonna go through 2 more examples, and that's pretty much kind of all we have in terms of just kind of thinking through how we use functions, how we use methods and objects. So here I have this object called calc. I have 4 values. The first one is num1, which is 20, num2, which is 30. I have this sum method, which just returns this.num1 plus this.num2, and then a difference method, which just returns this.num1 minus this.num2. Okay. If I just call console.log calc.sum, well, what's calc.sum? Calc.sum is, if I go to line 4, it takes me to line 5, it returns this.num1 plus this.num2, right? So that's 20 plus 30. So calc.sum is going to give me back a 50. And then on line 13, if I go in, I change num2 now from 30 to 15, and then I call calc.difference. Well, then it's going to say this.num1, which is still 20, minus this.num2, which is now 15, and 20 minus 15 is going to give me 5. So all we're trying to say here is that whenever we use this, it's not based off of like a previously stored version of this. It's dynamically, every time we use it, it's going into the object. It's going into the object and asking you what is the latest value in the object. Sure. Yep. Sorry. Yep. Yep. We're resetting the value. Yep. Right. And once again, right, all we're trying to say here is just to let you know that, hey, on line 12, when we read this.num2, it's different than when we read this.num2 on line 14, because in between we changed it, and whenever this is being called, we're doing it off of kind of like the latest live version of the object, as opposed to, a saved or a previous version of the object. Yeah, and so one thing we always do is give you a disclaimer. This is actually extremely complicated. There's a lot more it has to do with inheritance and prototypes, but we don't cover it in this class necessarily. Here we just want to give you kind of a quick basic primer of saying, hey, like there is this thing called this. It's a reference to the object, at least in the way that we've been using it. And it's very useful when you're writing object methods if you want to get a reference back to the object that the method is a part of. Cool. And that's pretty much it for today. So very fast lesson. Yeah, so sorry, so yeah, so today they're really